Hi, this is Dr. Behruz Fallahi. I'm with the Department of Mechanical Engineering at Northern Illinois University. In this video, we are going to talk about the preliminary steps that are needed for the position analysis of inverted slide crank mechanism type 1. Basically, we wanted to know what are the parameters we should introduce and what is the role that they play in describing the position and orientation of the links of the inverted slider crank mechanism. Here is the inverted slider crank mechanism. It consists of 3 moving links and 1 frame, so it has 4 links. This link here is the crank, and it is pivoted to the ground. The light blue link here is the output link, and that link is also pivoted to the ground. On the output link, we have a slot, and in the slot, there is another link, the green link, and it is the block. And the block can slide inside the slot up and down. At the same time, the plot is pinned to the crank here. Now, in order to start doing the position analysis of the slider crank mechanism, we need to know what are the vectors that we can assign to these links that forms a loop. Such a set of vectors is shown here. Those are vector R1, R2, and R3. It is very important that we know how they are constructed. Vector R1 is between the 2 fixed pivots. So this means that the length and an angle are constant, and they do not change when the mechanism moves. And they should be given to us if it is a textbook, let's say, problem. If it is a linkage in practice and we wanted to analyze it, develop the model to analyze it, we should go and make a measurement and find out what are the angles and the length of vector R1 with respect to a coordinate system of our choosing. Vector R2 is grounds between the 2 pivots on the crank. Therefore, the length of the vector R2 is constant, but its angle will vary as the linkage move. For vector R3, both the length and the angle vary. The length of R3 locates the block within the output link, and the angle of vector R3 orients the output link. Now I wanted to show to the class that if I have these parameters, by that I mean the R's and thetas, how can I assemble this mechanism, or how can I lay out these links on a piece of paper. First, I need a coordinate system. Once I choose the coordinate system, then I can put the first fixed pivot at the origin of this coordinate system. Then I can lay out vector R1, and then at the tip of vector R1, I can locate the second fixed pivot. I can lay out vector R2, and along with it, I can lay out the crank. Then I can lay out vector R3, and along with it, I can lay out the output link. I can also lay out the block and place the pin, which is on the block at the tip of vector R3. So you see that if I have these parameters, I have enough information to lay out or assemble the inverted slider crank mechanism. Once we identified, let's say, these parameters, we are going to divide them into 2 groups. The first group consists of the length and the angle of vector R1, and the length and the angle of vector R2. These should be given for position analysis of the linkage. and then we need to set up a mathematical equation, and based on that develop a procedure for computation of theta 3 and r3. This concludes this video. Would like you to, after this video, to watch the video on how to develop the equations for the position analysis of the inverted slider crank mechanism, and how and what is the let's say computational procedure based on the equation that we derived for this purpose.